Okay, I have began to record this. So this is a completely empty project, and we are going to set it up first. Then we will talk a little bit about ECS if someone has forgotten what it is, and then we will dive right into coding. So I have pasted a link here. It's a 0.45.1 version. So I have just checked out the latest store version. It's 1.2 something, I think, and it turned out it has some bugs and it's not really usable. So let's use this one. And in the zip file you'll find a lot of stuff like code generation, documentation, migration, and we only need the entitas thing here. So let's open the project, or we can actually drag it into the assets folder directly. I usually like to store external libraries in folder called libs, and we drop entitas there, and then go back to Unity. It sees it, imports, and tries to compile it. And while it's doing it, I'm going to add some art here. So this is our current project, and this is the imported stuff that I was preparing yesterday. Sources, space shooter redux. So it's just some images from the pack I've given a link here. So it has imported the entitas library, and as you see, it has created a tools menu at the top. And this is where entitas lives actually, and we are going to look at how to use that preferences window and all that stuff. So here we have some spaceships which we are going to use, and here's our entitas library. And in order to set it up correctly, you have to actually open some script in your project so that it generates a C# project file. As you can see, it doesn't have it yet, so we actually need to open this, for example, this compile file. And it actually depends on which code editor you open it in. So I'm going to use Visual Studio Code for now. And it's going to open the script and will generate the standard assembly C#.C# project file. And this thing actually is crucial. You have to copy it. Wait. You have to copy it and store it in the buffer. So then we go to Tools, Entitas, Preferences, and there is a button called Auto Import. We need to click that. It sets some interesting things to everything, like data providers, code generators. Don't let that stuff scare you for now. And it also has that C# project name here. So make sure that this name matches that name, because Visual Studio actually opens it with a different name. It usually, the name of the folder it's located in .C# project. So make sure that it says the same thing. And we will also delete this input context for now. So just to keep things simple. So after that, we have checked that it matches. We press generate. This is the first thing you need to do after importing and setting up Entitas. And as you can see, it has generated some code that is needed for us to begin scripting. And by default, it puts all the generated code into sources generated folder, and it has a lot of things here, so like some attributes, some contexts, and all that thing. So this is the entity setup part. So it should actually say that it has generated something. If it generates and doesn't give you any errors, it means that you have set it up correctly. So then we are going to save the scene, and we will prepare some prefabs for our player. Let's make it this blue one, set it up to 0, 0. Also, let's decrease the size of our camera a bit so it's a bit larger, and we are going to create a prefab of that. Let's call it player. We will also need some prefabs for our asteroids actually, so let's create one big. Let's actually reset it to, and let's create another folder called asteroids. Oh wait, I haven't shown you what we are actually making, so let's take a look. So this is the example project. It has a ship that shoots, and then the asteroid splits, and it splits up to like 5 times or so, and you need to actually shoot them. So this is more or less what we are going to make today. We have one big asteroid, and there are 2 more. Big 2. Let's make 2 of each. One medium. Another one medium. Too small and too tiny. I'll actually leave one small because they don't differ that much, and one tiny. Let's also change the background color of our camera so it's a bit more dark. So we can say that we are set up. Like we have some prefabs, and we have, oh wait, we don't have a laser prefab, so I like this one. Now we are set up. Who needs to refresh the memory about ECS? So, well, a common question that rises up when we are discussing what is the difference between Unity's component system and the system that we are looking into right now, like entity component system. And the difference is quite apparent because usually components in Unity have both data and logic. Let me open an example. No. You can actually check it out for me and ask if something goes wrong on interesting there. It has a lot of oh, there's our Simon. Yeah, okay. You can read the chat for me and ask if anyone notices something. Okay. So yeah, let me check. Where is it? Introduction. And there is a, let's say, a graph of how does it look like. Like, as you can see, entities can have some components, and components consist just of data. They don't have any logic. And Entitas actually makes sure that we have our entities stored in the contexts directly. So context is a thing that manages the lifetime of entities. It actually serves as a pool. So if we destroy entities, they are not actually destroyed. They live there disabled, waiting for us when we create another one. And we also have a notion of groups and collectors and all that stuff, but it's not clear where do the systems fit here. So the systems actually are handled directly by us. So this thing actually is just data, like entities that have components that have data. Groups are just a set of entities with certain components, like we have, if you see here, overlapping groups. We can have different groups, and we will use some of them during our example here. So let's create our first component, and I will put my components here in the scripts folder. Let's create a folder called components, and it's usually up to you to decide where to put your components. Some people like separate storing the components from storing the systems on which they operate. Some actually separate components and systems by the feature that they implement. As we have a pretty simple example, we will use just this components and systems folder, and we will also put some Unity specific code into the root of the scripts folder. So let's create our first player component. I think the code is visible. I can make it light if you want.
It's okay.
No?
Oh, either way it's okay.
Either way, okay. Let's leave the dark one because I don't remember which one this was. Yeah, this one. So in order to create components, you need to add using Entitas here, and you need to implement an empty interface called iComponent. It's actually needed for the code generator to work. And this component won't have any data. It will just say that some entity is a player. And by default, components usually go into the game context. So this is what we are going to use. Don't cram your head around it too much. It's just some stuff that is needed for the code generator to work. You can actually omit it, and it will put it in the game context by default, but we will use this notation here just for explicitity. So we have created a player component script. It implements the empty iComponent interface, and it has a using entities, and it has a game attribute. After we have created the component, we need to go and generate some code. So it's either tools entitas or tools Genie generate, if it depends on entitas version. But right here it's tools entitas generate, or Control-Shift-G, which I will use extensively in this example. And as you can see, it has generated some code, and it also prints some error like reloading assembly code from managed code. It's a known issue with it, and it appears only the first time you generate ever. So let's check that we have actually generated some code. And as you can see, in the generated folder, it has game player component script. It means that it has generated it correctly. And after that, we can actually use it on our entities. And as we are making Unity game, we actually need some objects to live in the Unity side. So there are usually game controllers that serve just that purpose. So game controllers are used to glue Unity layer with the Entitas layer, because Entitas by itself doesn't know anything about Unity. So we need to create a vanilla mono behavior script for that. Let's call it game controller. And it's a simple mono behavior. We won't even delete that, and we will leave this start and update methods too. And we have looked at the simplest component script, and let's look at the simplest system script. And the simplest you can get is just hello world system, and let's create that just to check that things are working. And there are different kind of systems in Entitas, and we are going to use initialize system in this case. Don't forget to using Entitas, and we are going to implement initialize system. And initialize system interface is not empty. It actually has a method called initialize, and this is where we are going to print our debug log message. And debug is in the engine, Unity engine, debug log hello world. And as you can see, it doesn't have anything to do with Unity itself, except debugging. So we need to actually glue this system to Unity, and so it can actually debug something. And in our game controller script, we usually create all the systems up front, so we know the order in which systems are executed and initialized, and they are stored in the helper systems class. Private systems, yeah, don't forget to using entities here. Systems, and systems class is just a, let's say, a wrapper for all the systems that your game has, and you can actually call initialize method on all initialize systems, call execute methods on all execute systems, and so on. So it's usually done by implementing a create systems method. And there is also a thing called a feature that is generated here, as you can see. It's actually a wrapper around the systems class, which has a name, and which also allows us to see some visual debugging in Unity. So feature class actually knows about Unity, and we are going to return that. We'll return new feature. Let's call it game, and you'll see why do we need to call it something. And there's a fluid interface for that. We need to create hello world system here. So we at least create something, and let's actually call it. And after we have everything set up and ready, we can actually call initialize on it. So after this, hopefully it will print our hello world message in the console. What do we have going in the chat, Anton? Nothing. Okay. Yeah, it doesn't print anything. Guess why? Because I haven't put game controller script on my object. Yay, we have a hello world. Now we can actually start implementing some useful stuff, not this hello world thing. So as you can see from here, we actually have some context, but we don't have anything like that yet. So context is in Unity usually is handled by using the shared instance singleton. And it's usually the easiest way to do it, but it's not the only way. So you can create the context yourself and pass it everywhere. So, but just for simplicity, we will use the common shared instance method of using it. So it's called contexts because we can have a lot of different contexts, but we'll use only one, which is called game. But we still need to have the context instance here. So because it's the usual way of dealing with it. And we usually need to pass these this context reference to our systems, so we will do that up front here. Pass it here. And now we have a context in which we need to put some entities. And the first entity is going to be a game setup entity which has like links on prefabs here, so we can create our player, create our laser, and our asteroids. So let's create a simple scriptable object called game setup. Do you guys know what the scriptable object is?
Yes.
What is it?
The scriptable object is actually like it is used for creating common types of objects, usually like some kind of items, probably in games.
Yeah, exactly. And this is what we are going to use. So we will link our player prefab here, and I have added this create asset menu attribute here, so we don't need to write our custom create menu. It's right here, create game setup. Let's call it game setup, and we will link our player prefab here. We also need a reference to this in our game controller, so we can actually pass it to our entities layer, like game setup. Let's link in here, and I will show you a cool feature of entities that allows creating components from non-entities types. Like this game setup is actually a scriptable object, and it doesn't implement iComponent interface, but if you put a game attribute here, it's going to actually generate a component for it. Like here you see it doesn't have any additional components, but when I put game here and generate again, Ctrl-Shift-G, it creates another folder which actually creates a game setup component for me. Like it looks like this. So it has a reference to the game setup object. And there is also a cool thing in Entitas, which is actually not always a part of traditional ACS. It has a notion of unique components, which represent components that can exist in only one copy across the lifetime of the game. And this attribute, as you can see, needs a special using statement, entities code generation attributes.
I will make some comments. It says that I usually create the class game systems feature instead of the create systems method. It's better for testing and it makes the game controller script simple.
Yeah, sure. I have used the same, like people here say to me that game systems feature classes. Oh yeah, they also check out the Unity jobs thing there. So yeah, you can look at the other example of entities, and you'll see that they usually have some separate classes for features, but for simplicity we will use this one, and if we have some time I'll show you how to extract it further. So I have added a unique attribute here, and we are going to generate again, and it actually created another component for us with unique attribute, and it has created an extension which allows accessing components directly from the context, but we will look at it here. So one way of passing this game setup scriptable object to our entities layer is to actually create an entity right here. So let's create our first entity. We need to create an entity from the actual game context, because we can have different contexts, but in this case we only have one, which is called game, and we create an entity there. And this entity can have a game setup component, which add component, add game setup here, and we pass our game setup reference here. And that's the only the one way to do it. Another way, as we have specified our component as unique, we can actually access our game setup entity directly by using contexts game set. I think I have not updated the project, so let's close it and reopen it. Visual Studio Code sometimes likes to do it, and it will have the needed extensions. Contexts game. Wait, it thinks. Yes, here it is, set game setup, and this line is actually looks somewhat like this, but the API is simpler, and we can actually see that this component is unique because we will have only one. So this line here is almost equivalent of these two lines here, so creating an entity and putting a component on it. So this line will probably create our first entity with a game setup reference. So let's check it. And Entities has a layer of visual debugging, which actually doesn't work in the builds. So it's editor only, and we can see that it has created an entity with a game setup component, which has a link to our scriptable object. And this is how we have glued our game setup scriptable object to the entities layer. So let's create our first actual working system, which we'll call an initialize player system. And as you have guessed by now, it will be an initialize system. And it will surely have our initialize method. And in this method, we are going to somehow create another entity. And in order to create an entity, we actually need a reference to our contexts class. And we can surely use like contexts shared instance here, but it makes the code harder to test. So we are going to use a more right example of passing contexts as a dependency in the constructor. And we'll have a private field, and here we can actually create another entity, like contexts game create entity. And as our player component, like player component doesn't have any data, the API for this is not add player or something, it's isPlayer true. And let's don't forget to add that to our game controller after our hello world system. And it actually needs a context instance, so this is what we pass. And let's actually leave it so that we know that it works. And let's check that we at least have some abstract entity with a player. As you can see, we have two entities here, one with a game setup, which we have seen already, and one with a player flag component. Now we actually need to add some Unity viewable stuff, and we will need a component for that. Let's create a resource prefab component, or just a resource component, and this component will actually work as a holder for the prefab, and we will be able to see why do we need it when we actually start working with reactive systems. Like the logic will be, if we add a resource component on an entity, it means that we want to create an instance of the game object in Unity on the Unity side. So we will have some system that checks for the new resource component entities, and it will instantiate that prefab and will put it inside the entity as a view component. So the resource component will have a game object thingy here. So prefab, need to put a game attribute here. Guys, if you have any questions, please feel free to ask if you're not following or something. What do we have in the chat? Let's generate. You need to generate after every addition of component. Like if you have a few component added, you need to go back to Unity and generate. So we have our resource component, and we need to have a view component. And the view component will actually hold a game object instance instead of the prefab. So another component here. Game attribute and our game object value. Don't forget to generate. And let's add a resource to our entity in the initialize player system. Entity.add resource. And as we know, the resource is located in contexts, game setup, and it has a value that is generated for us, and a player. It's actually a prefab. I should rename it. Player prefab. Oh wait, Visual Studio Code doesn't have cool renaming. Okay, let's leave it as a player for now. And let's check that it actually creates a component with a prefab reference. Player resource, and as you can see, this thing points at the correct prefab. Now we need to add another system, and this kind of system is actually the most used in Entitas. It's called a reactive system, and it triggers not every frame and not only once like initialize systems. It actually triggers every time something interesting happens. So if a system tells us that it needs the addition of the resource component, if we add a resource component to any entity, it will fire and will work its logic. So let's call it instantiate view system. And reactive system are a bit more tricky to implement because it needs to know the type of the entity for which it is created. Like in our case, as we have a game context, it means that game context have game entities, but don't bother about it too much right now. Don't forget to add using entities, and as you can see, it tries to tell us that it needs to actually implement something. So the first thing, I don't know why Visual Studio Code puts it in the reverse order, but it's usually more convenient to look at it like this. So the first thing is called getTrigger. It actually works as a way to tell entities which, let's say, component events are needed to be handled. In this case, we are interested in resource component addition. So we will create a new collector, which is created by using context create collector, and it has some parameters like game, matcher, resource, and by default it means resource.added. Like I can add it here, added, and by default it uses that internally, so we don't need to do that. There are also some things like removed, added or removed, or something like this. So there is a lot of group events. After that, we need to actually filter our entities. Why do we need to filter them is because by the time this system actually handles the entity, it may not have that component in which we are interested in. But in this case, we are actually interested in this component both here. Like we need to know which entities were added with the resource component, and we actually need that resource component to be used in the execute method. So we need to double check it here. So it's not 100% true that any entities will have these components here by the time it's executed, and we will most likely check out how it works a bit later. And the last thing is the execute method, which is supplied with an entities list here. So we can just for each over it, our entities, and by this time we know actually that this entity has a resource component, and we don't need to know anything about this entity except that fact. It tells us that we actually need to implement something more, and it's a base constructor. So let's make it happy. It needs us to pass a game context there reference. So this is what we did here, and we also need this contexts reference for ourselves in order to create new entities there. And we can actually create new entities here. So this system will only handle the case where we have added a resource component on it, and it will create a game object view instantiated for it. So we don't need to create another entity. We will put actual game object on it. So entity, like let's first create a game object, and it will use an object instantiate entity resource value late resource prefab. This is Unity stuff. Like object instantiate has nothing to do with entities, and right now this game object is like handled by Unity only. So we need to actually link this game object to our entity and our entity to the game object. And to link this game object to our entity, as we have seen it, we have created an add view component, and it needs us to pass a game object there. So this way, this entity has both resource and an actual view there. And we also can link our game object to our entity, and there is a link method which takes an entity and a contexts reference, like this context. As you can see, it doesn't know anything about it because we need to put another using statement here. As you can see, it has the squiggles disappeared. And wait, I think that's a, yeah, let's add this system to our game controller after the initialize player system, instantiate resource, instantiate view system. So we have one system that creates a resource component and another system that feeds on this resource component. So these systems actually are decoupled as hell and can't be decoupled any further. So let's check that it actually works. Let it compile. We don't need to generate anything. And it seems that it doesn't generates any views there. So, oh wait, I have forgotten. We only call the initialize here, but reactive systems actually need to be called an execute method. So we don't call it anywhere, so it's not run. And execute method is your usually update method. So start is initialize, execute is in update. Let's add a execute call here and let's check that it actually runs. Yay, we have both hello world and our player. Oh, it surely may seem like a lot of work to spawn a player prefab, but it's actually a very extensible way to do it, because we can actually test it without a lot of hookups and all that strange things that make it sometimes impossible to extend a Unity game. And as you can see, if we put different coordinates in the player prefab here, it spawns at a different place, like this, where it has spawned. It's not even visible on the screen. So let's add a position, or like initial position here component. Let's call it initial position component. Using, and let's create a simple vector3 value and put a game attribute here. So this component will be used by our initialize view system, and if our entity has an initial position component, it will try to set that as a position of our new instantiated view. So let's check it here. If entity that has initial position, it means that we have specified it, and we can actually game object transform that position equals entity initial position value. And in our initialize player system, we will add an initial position vector 3.0, so it always spawns at the center of the screen. And we will use the same logic to spawn our asteroids. So as you can see, the prefab has a position of 5, but it spawns at the center because it has a position component, initial position component. So we need to hard code and put that here. Now let's create. We have two options. We can add asteroid spawning right away, or we can implement ship control first. What do you guys think we should do first? Asteroid spawning or ship control?
Ship control.
Ship control, okay. Yeah, like there are actually several ways of handling Unity input, and as everything in programming, you can do like 100 different ways. So I'm going to make an additional system for that. So the system will be, just to show you how execute systems work. This system will actually be called every frame in the update, and will check the current input values, and we'll change some unique components for inputs every frame, which we will use in 2 different systems to control our ship. And in this case, it is going to be some execute input system, or just like input system. There are also ways to supply this input values directly from mono behaviors. Like we have a game controller, we can have some input emitter controller or something like that, which is a mono behavior and doesn't work as a system. But we don't always can, we're not always able to disable it like via code. We can disable the component so it won't receive any updates, but like, well, it depends. It actually, there is 100 ways to do it. And yeah, we had 2 initialized systems, and we had 1 reactive system. Now we need another kind of system, which is a execute system, which is also located in Entitas namespace and has 1 method called execute. We will also need our favorite contexts. Reference. Which we will pass as a constructor. Wait, it doesn't have any base. A constructor dependency injection. Yeah, you can actually write some code generators that, like in ReSharper, it has live templates, and it will generate this thing for you. Like every execute system will have probably this private context reference and a public constructor which takes a context reference and sets it to the private field. But I don't have this thing in Visual Studio Code. It's not my, actually I'm not very familiar with it. I usually use this Visual Studio, but for the sake of the speed, because it works faster, we use it now. But you don't have to write everything by hand. So this input system will work as some kind of a Unity input manager. It will use, we actually need, Unity engine to be able to check for the input. And let's check that we actually have something. Yeah, Unity has quite a few input axes defined already, and we will use horizontal axis, vertical axis, and a jump for fire, because these fire 1, fire 2, fire 3 are bound to left control, left alt, and like left shift, for example. Yeah, but we will use jump. We can actually rename it to fire just right away, fire, without a number, so it's not jumping but firing. Okay, we'll use horizontal axis and a vertical axis here. So horizontal get axis, just some usual Unity stuff. And let's check actually that it works, just to make sure. And I will use a raw value here so it doesn't add any smoothing to it. Oh wait, who will say what I have forgotten and why doesn't it work? Yes. It's a common problem. I always forget to add these things here. Input system, and I will put it at the beginning here. Or Oh, like, it doesn't really matter in this case.
This game controller, it's standard mono behavior.
Yes, it needs to get the start and update methods, so it knows when to call the execute on systems. This is why we need mono behavior. Yeah, it says that I don't use contacts, but just for now. Let's check that. Yeah, as you can see, it prints 0, and if I press left or right, it prints 1 at the x-axis, and if I press up or down, it prints 1 or -1 at the y-axis, and we need another unique input component. Component entitas, and we are going to use other attributes. We will need a game and unique, because our input is unique per game. Like, you can imagine having 2 different players playing with 2 different ships, and in this case it won't be a unique component. It will actually have some application to a certain player, but in this case I will use a vector 3 for this, just for simplicity of adding the position. Input, oh wait, value, yeah. Who can say what we are going to need to do next after adding a component? We have added a component, and in order to use it we need to do what?
To make a system that uses?
No, before that. Like, we have created a component. What do we do after we create a component?
Generate.
Yes, generate. Like, create a component, and the next step is always to generate, or it won't be visible in our... Where is my input system? Yeah, here it is. Right here, as we have a context reference, we can actually game set or replace input. There is a API for that. Horizontal, vertical. Wait, it needs a vector 3. So new vector 3. Horizontal, vertical, 0. Cool. Let's see how it works at the entity side. It should probably create a input entity. As you can see, it doesn't constantly create and deletes entities. It's actually the same entity all the time, but as you can see, it has changed values when I press the buttons, so there is no overhead like of creating and deleting entities from that. Now we need to implement our player rotation, and just like, again, for the sake of simplicity, we will use the Unity position here, so we won't have a mirroring position component to handle it in the entity side. We will let Unity do that for us, so we will use a up vector of this object, because 2D objects in Unity, their forward is actually pointing up, and we will use their position as it is, so we won't have additional components for that. But in order to rotate it, we need to actually add something to our game setup, like float rotation speed, and it is measured in degrees per second. So rotation speed 180 degrees per second. Our player ship should rotate just using that. So we will have another execute system, which we'll call a rotate player system. Wait, it's not a rotate player, it's an execute system. And which method do execute systems have? I execute method systems. We have created like one execute system just now. Yeah, there is a guy, Daniel, who asks, why do you add unique? What if I want a second player? Well, we don't have a second player in this case, but if you do want a second player, you need to pass some kind of a reference between input and player. So it will probably require two systems, or like one system that can map input to certain players. But just for the sake of simplicity, we are using a unique input here. Maybe we have time, we can actually ununique it and make it so that it references the player, like by ID or by a component, whatever. And our favorite systems boilerplate code. Yeah, I actually have some live templates in there sharper, but not here. And this system will, using some logic, rotate the player. So like let me just refresh on that. Yeah, we have, I'll just copy it here. Wait. And we'll just explain what it does. We have our input value, which is X, like we rotate with arrows or A or D buttons. We have a player transform, which doesn't have player entity here because player is not unique, maybe. Let's check. Player component. Yeah, it's not unique. Let's make it unique. And again, if you don't want these things to be unique, it's totally okay, because in this case you are just going to handle an array of entities instead of just one unique entity. We have added another attribute on our player component. This is why we need to regenerate in order to access that new API. And now we can actually uncomment it, and it still doesn't compile because Visual Studio Code doesn't know anything about it. And we need to reload it because like I know for sure that it has added there. Like game context can give us a reference to the single player entity which is marked as unique. This is what we use here. So unique entities are actually not handled by the context itself. They just are simple entities like you create yourself, but you can access them using this like semi-global reference here. So we have our input, we have a player transform and current player rotation in earlier angles. And sorry? Yeah, it's just I need to put it on the next line here. So time is here, like it's also a Unity API like time delta time, but usually used to have delta time component which is handled by replace delta time system, which queries it once at the start of the frame, and all the systems use that instead of like asking time.delta time, because this call actually has quite a lot of overhead, and if a lot of systems use it, it will slow your game down. So, but in this case, okay, for simplicity, we will use like 3 systems with it, so let's use that. And we need to actually subtract our input vector, like x value of the input vector, multiplied by the rotation speed multiplied by past time since the last frame. And this is why and how we get our 180 degrees per second. And as Unity starts rotation in quaternions, we need to create a quaternion from our earlier angles. And it will handle all the looping nicely. And let's not forget to add the systems here. And hopefully it will rotate the player. Yay, we have a rotating player. And as space doesn't have any notion of drag, we are going to handle some kind of acceleration. And we need an acceleration component. This component will have a vector 3 again. And it's a vector 3 and not vector 2. Like, why do we need a vector 3 thing if we use only 2D movement? Because of the simplicity of handling this thing, like player rotation.z, we can actually just, as the position is a vector 3 itself, we can't, without any additional wrappers, subtract one vector 3 from like vector 2. This is why we will store acceleration as a vector 3.
You can use standard Unity physics.
Yeah, that's one way to do it, and we will actually use physics as triggers. But in this case, like it will, yeah, it's one way of doing things, and we will need to reduce some drag on every rigid body and like that. So it's one way of doing it, but just here to show how to do things in different ways. So we actually have a game that uses physics a lot. It uses colliders and wheel colliders and all that things, and we don't need to simulate any of that ourselves. But if you need some kind of like cross-platform multiplayer using physics, physics that is built in Unity is not deterministic, so it uses floating point arithmetics, which are prone to error and are hardware specific, because every CPU vendor tries to get as much performance of it as it can. So in this case, people usually implement like some integer based physics or something like that to make it deterministic. So where was I? We have an acceleration component, right? We need to generate. And we need to add an initial acceleration to our player, which is also going to be a vector 3, 0. This means that entity already has a component, but its value is 0, so we can safely query it in our move system. Like, where is it? Acceleration entity, yeah. This is our player entity, and as you can see, it has a resource, a view, a player flag, initial position, and acceleration. Right now it's 0, but in order to use it, we need to actually create another system called move system. It will take an acceleration vector, which is not a normalized vector, but actually is a vector with different magnitudes, and it will move our entities with acceleration component by that vector. So there's another notion in entities which is shouldn't rotation system only set rotation on the entity and the separate reactive system should modify the transform? Yes, that's one way to do it. If you need to decouple everything, your code from the entities code, pure C# code from Unity, this is how you should approach things. But as I've said, just for the sake of simplicity, because we only have 3 hours here or so, yeah, we will use that. But that's actually a way to do it. And as you can see, this on this diagram, it has a notion of groups here. And this is what we are going to use, because we can have quite a lot of entities with acceleration, and we need to move all of them in using some common logic. So we will need a group of entities with an acceleration component. And because right here in this implementation, we also depend on moving actual transform of the entity, we will also need a view component. So our group will have both acceleration and a view component. But if you, like the Slim shader, want to decouple everything that is Unity based from your game logic, you will also have position component and all that stuff, and then some gluing systems that will use Unity. I don't need attributes on my system. I will need to implement it, and let me just quickly copy it here. Yeah, copy and paste, my favorite part. It's okay to store a group, as I remember correctly, iGroup game entity directly in the system, because it's not considered a data layer, because to get that data, you actually need to query group for its entities. And we have a group reference here, and we need to create it, and it's created by context game get group. It's create collector, because collector are per system, but groups are usually common. If they can be batched together, they are batched. Game matcher, matcher all of. We need to have both components, both view and an acceleration. Game matcher acceleration and game matcher view. Let me, yeah, iMatcher maybe, or game matcher. I don't remember. Yeah, game matcher. Boom, boom, boom. This thing here creates a group that matches entities with acceleration and with a view. So this group only contains entities that have both acceleration and a view. And right now, the only entity that is can be handled by this group is our player, because it has both acceleration, which is a 0 right now, and it has a view. So in our execute method, we can actually for each of those entities and groups actually have an iterator built into them, so we can put group directly into for each. And there is also another way to get entities, like this get entities. It creates a temporary array, puts some entities there, and gives it to you. And what's the difference between iterating over an iterator or creating a intermediate, let's say, array? What's the difference? What do you think? Why do we need two kinds of APIs? Why can't we just use this one? Yeah, actually iterating over an array is faster, but at the cost of some garbage collection pressure. But actually in this case we say that, like in this version of C# at least, we say that we don't remove acceleration or view components from that entities, because in this, if we say like entity dot remove view, it invalidates the group, and the group stops having that entity here, and the C# doesn't like when the collection changes on the fly, and this is where we get some errors. And this, if we need to actually remove some components, we need to call get entities. And there are people that write some extensions for it in order to not create that temporary array. They supply a temporary list that is cleared and then filled up with entities, so you don't have that GC pressure. But in this case, we don't actually need to remove any of those components. We just need to move it. So we are okay using that built-in iterator. So let's actually move it. So we have our view entity dot view dot value, and we have our acceleration. Oops, not else. Acceleration value. And a view is a game object. Yes. VF. It's not VF. It's view. And it's a simple like linear algebra view, like position, view, transform, position.
There is a question. Why do you make sure view? Because there is game object. Position change not enough.
Yeah, like I don't have a position component. I only have an initial position component, which is used only when we are creating views. So that initial position component actually is needed only to instantiate views on a specific position, which we will need when we will create some asteroids. But yeah, like if you have a different approach, like if you have position component, which is which matches to the Unity's built-in transform and position. In this case, you will have a position here, but I don't have it. Like we have only initial position. So this is why we need a view, because we have decided to use the internal transform and position values just for this case. But yeah, it's that's how you will probably make it if you are making a serious game. We need to move our position by acceleration times time delta time, and it should probably work just like this, even if we don't have a system that actually sets the acceleration. And I will show you a cool feature that allows us to change data and control systems without actually needing to have certain systems, because visual debugging in Entitas allows just that. And you see that like we only have a rotation. We don't have any system that handles vertical axis of the Unity. But we have an acceleration, a move system, which checks the acceleration entities. And if we change our acceleration vector, as you can see, well, nothing happens. I wonder why. Let's check that. Maybe move system maybe doesn't have that values. Like let's check here, debug log. Oh, I want to be debugging here. I just check out acceleration and view. I group. Looks okay. Looks the same. Oh wait.
Shouldn't be velocity, like?
No. A penny to the one who says what's wrong here. Like we need to move our view like a game object. Why isn't it moving? I will make code bigger. Like Unity gurus, please.
You don't assign.
Yes, I don't assign this position back to the transform. Okay, let's check it.
I already asked.
Yeah. We still don't have an acceleration system, but we have a move system, and let's try changing the acceleration. Yay, it's moving. Like if I...
But now it's basically velocity, not acceleration.
Oh yeah, right. We can rename it just to... It's just it's called acceleration because actually when you pressing the input, or it should actually be called something like how does it called? Inertia, just like that. So not acceleration, but like and not velocity, but inertia, because inertia is a can be a three-dimensional value, but I have called it maybe not very correctly acceleration, because when we are pressing up or down arrows, we are actually changing its value. So okay, we can rename it or we can leave it like this. What do you think?
Leave it like this.
Okay, let's leave it. So we need to replace acceleration system, like which will also use an input entity, and in this case it will use a y-axis of it. So we are actually able to, how is it called, to break. If we are pressing down, we can break. We don't need this, and we need this, and we also need this. And this system will look like this, except that it will replace the acceleration, so it won't even need anything except the acceleration component on our player entity. Let's implement execute system, and let's take our input and a player here, and instead of rotating it, we need to actually, oh wait, we don't need transform, we only need input and a player entity. Player entity, and as we know, this player entity is surely supplied with an acceleration component, and we need a y value. Oh wait, we actually need that transform to actually get a forward vector, which is actually a up vector in notion of unity. So this is our player entity, this is its transform, up. It's called forward because it's easier to understand.
In 3D, but up in 2D.
Yes, because forward actually points the z-axis, but up points the y-axis, and this is xy plane that is used in 2D games in Unity. So yeah, we have a forward vector, we have our input value, and we need to multiply this vector by input by some speed, game setup, movement speed, public float, player movement speed. Let's say it's going to be 5 for starters. Player, replace, accelerate. Let's, to make it a bit easier, acceleration of value, player. And yeah, a very important thing here, I wonder why I have forgotten it, is that changing the components in Entitas or like in any ECS, if it's implemented correctly, should be done using a notion of immutability. Like if we change something, we need to replace the whole component, so the other world, like the outside world and all other systems or whatever managers are there, know that something has changed. This enables us to make applications and games which are reactive by default. So it's not like MVVM where you have to implement some iNotify property changed everywhere, which has a lot of boilerplate code. It's all reactive by default. So if you use this notation, like replace acceleration, replace something, we can replace view, replace remove. All of our components have replace API. So replace acceleration, replace game setup, initial position, input, and so on. In this case, we need to replace acceleration. Acceleration, which is a vector 3 plus input times forward times let's move our movement speed here, game setup value movement speed times movement speed times time delta time, and let's put it on another line here. That's it. We don't need to do anything except this. So we don't actually move our player here because this is what our move system does. We actually just take our input and replace the acceleration value. This way we can share this move system for all entities that will have acceleration. Like our asteroids and lasers will also have acceleration, and our move system will handle them all, because the only thing it needs is acceleration and a view. Like, don't forget to add this to our game controller move system, input system, rotate. Let's put our replace acceleration here, and let's check it. Yeah, it starts moving, and we can actually, and we can break too. So it's a real spaceship, yay. Now we need to actually spawn some asteroids, and for this we are going to need to supply our, like, why doesn't it open? Because we can have different sets of asteroids. We have big, medium, small, and tiny. We'll need to have arrays of prefabs, like bigs, mids, smalls, and tinies. We have 4 arrays of prefabs, and I will just quickly link them here. Yeah, and it's not actually the only way you can do it. Some studios use a resources folder and add resources as strings. Like, you can have a resources folder and your resource component will have a string value, so you can make a resource.load. You can also have asset bundles, but like in this case we will need all of these objects right away, so why don't we just go and load them right when the scene loads. Yes, we have our asteroids and we have a laser, which we'll also need to put here, so let's call it a laser. Let's actually first create a laser shooting behavior, and then we will create our asteroids spawning. So in order to spawn a laser, we don't need to actually have anything except the system that will tie our spacebar pressing to some entity creation. So let's create a system that we'll call a shoot system. And this is going to be an execute system also, because input is something that is handled every frame, and it will check for the fire get button down. Let's add it right away so we don't forget it. Rotate player input, let's add it here. Shoot system. Pew. Let's check that it works before we start adding some serious stuff. Yay, we have a compiler error because we don't need a context here yet. Pew, pew, pew. Okay, it works. Now we need to create an entity, and to create an entity we need a context reference. And we need to put two components there. It's going to be a resource component, add resource, context, game setup, value, laser, and it's going to need a acceleration component, add acceleration. And acceleration is going to be a vector that is rotated the same way the player is rotated, and it's going to move using some like laser movement, laser speed, 10 units per second should be okay. Player forward, game player entity view value transform, oops, up. Player forward, it's a unit vector, so we don't need to normalize it. Times, let's put it here. Oh. Setup laser, setup laser speed. And this entity should probably work just as we expect, because when we shoot, this system will create a view, a resource component, which will be handled by this instantiate view system, and the move system will automatically handle added acceleration entity because we created right before the execution of the move system, so it's going to be moving right after it has been created. So this order is crucial here, actually. So let's check. Doesn't have any errors. Yay. But we have forgotten one thing. Like what? Why doesn't it shoot from the player ship?
Because we don't have the system that is responsible for it.
No, we need to add an initial position component too. Add initial position, and it is going to be a player position. And as our instantiate view system automatically handles entities with an initial view position component, yeah, it starts shooting. Oh wait, it's not all. What else do we need to do? Yeah, we need to actually, and where do we need to do it? Like in our move system. Wait, let me check that.
When we instantiate it,
Yeah, it's better to do it when we instantiate it because our lasers won't actually rotate at all. Player transform, but we don't instantiate it here. Like, wait. Maybe our chat users will tell us something about it. Yeah, let's wait for that, and we will create our asteroids right now. So there are actually ways to make a rotation. Like we can always rotate our things that are moving to the point of their movement, but in this case our player won't be facing the right direction. So yeah, let's leave it for now. We need to spawn our asteroids, and it is going to be which kind of system if we need to do it once? Yes. It's going to be an initialized system, and let me just quickly copy paste because we will also need
Can you remind me what types of systems do we have? We have
initialized system, execute system, reactive system. We also have a cleanup system and a teardown system. And a cleanup system is used when we need to, well, like clean up after the frame has ended processing. Reactive system work as execute systems, like they need us to be calling execute on them through the systems. And teardown systems usually are usually used. Oh wait, I have pressed the wrong thing. Yeah. And teardown systems are usually used when we are exiting the scene. So it actually, our initialized system, we don't need it. We need to do this. Oh yeah. It has decided to not update again. I think it.
What is the purpose of reactive systems if they behave the same as execute?
Execute systems, as you have seen, don't have a notion of, let's say, move system is an execute system, so it doesn't depend. Oh, move system is actually a reactive system. No, move system doesn't depend on like events of adding or removing components. Like if you need to do something every frame steadily, so like if you need to check for the input every frame, or you need to move something every frame, because it doesn't like, you know for sure that something is going to happen every frame. In this case, you are going to need an execute system. But if you, like in the example of views, don't exactly sure that something will happen every frame, like instantiate view system. In this case, we will instantiate things only when either we initializing our scene, like we need to instantiate all of the asteroids and the player, but we also need to instantiate lasers when we press our spacebar, and we won't be able to press our spacebar every frame. Like in this case, it's actually not a very common scenario. Like it's going to be happening a lot, but not every frame. In this case, we can surely say that we need a reactive system that is going to be called when something interesting happens, like to react on some changes in the underlying layer. And usually the reactive system is the most used because it actually allows us to somehow, like in some way, what is it called? Reduce the number of resources we need to execute code. So in this case, even if we don't have any entities in our group, we will still need to for each over it, and it will tell that no entity is there, and it will still call this method. But in reactive system, this method won't be even called here if we don't have any newly added entities. It still doesn't initialize system. Why doesn't it let me? Let's see if Unity will be happy. No, it still doesn't happy. It's still not happy. Because I have misspelled it. That's why it's not happy. And in this case, we are going to just hard code 4 asteroids. But it's up to you whether to put it in some kind of settings or game setup or whatever. So we need to create 4 entities with an asteroid. And our asteroids will be explodable. And so we need an asteroid component that will hold current level of bigness of the asteroid. So asteroid component. We may not necessarily need a laser component, but we will definitely need an asteroid component. And it is going to have a int level value. And it will start with a 3, so it's a big. Like if we start with tiny, it's 0, 1, 2, 3. Big is 3. So by default it's 3. And entity add asteroid. Yeah, I have forgotten to generate. Asteroid 3 is 3 by default. We will also need some kind of system that maps this asteroid level to an actual resource. So, but we will also need an initial position here, and it will be a random number. Entity dot add initial position, random range. I know that my camera size is 3, and 3 is half of the screen height. So we are going to spawn our asteroids like this, blindly hoping that it will fit in our view. But you can actually have some complicated calculations, like how big is your view.
Can we take the view constants? And the screen has something to
Screen?
The range, yeah.
The screen class actually handles everything in pixels. So, but the Unity has like position is like if we have our player in the scene, it's not yeah, it's actually 0, 0 is in the center. So, and if we put it at the right side of the screen, as you can see, its position is 3.95, not like something that is here. It's clearly not 4 pixels wide. Yeah, so you will need some kind of mapping between Unity units and actual screen pixels or screen size. You can actually calculate actual size by this thing. This thing is half of the screen height. So if you know this value and the camera aspect ratio, you can multiply it, and it will say what is the half width of the scene, and you can use that. But I will not do it here because I don't like complicated math. Yeah, like we have added. Sorry.
Nobody likes.
Yeah, we have added an asteroid with a level of 3 and added a initial position here. So one thing we don't do here, because we do it in another system, is actually instantiating game objects. But we can't, yeah, surely we can add actual resources here, but this way we'll have a lot of code duplication. So we will create another system that will map an asteroid level to the actual resource, and it will be a reactive system because we will actually replace our asteroids a lot. So map asteroid level to resource system, and it will do just one thing, like it is going to be a reactive system, and you will tell me why in a second. Why do we need it to be a reactive system? Yeah, let me just copy and paste to save some time. Like our move system is an execute system, our instantiate view is a reactive system. I'll just copy and paste it here. And let's replace it. In this reactive system, we need to handle the case when the asteroid level is changing. So this is going to be a asteroid added or removed, or we can actually leave it as it is, because when we replace components, it calls a removed event, and then calls an added event. So replacement is actually both of those events. So it will call both added and removed. So in this case, we will leave it as this. By default, it's added. Yeah, like why doesn't it? Abstract member, reactive system execute, list game entities. It's right here. Why doesn't it handle it? Let's, oops, map asteroid. Yeah, Unity makes this compiler errors better looking. Execute list of game entities. Why doesn't it compile? List could not be found. Okay. Oops. Because list is in collections generic. Everybody knows that, except Visual Studio Code. Yeah, like in this system, we will have a list of asteroid entities, which will probably have, like, not probably, yeah, I have fallen into a pit of copy pasting. I haven't replaced this line of code. Good news, I have spotted it right away. Has asteroid for each. And this entity is surely has an asteroid. Like we have asteroid here, and we need to our mapping function, game object map asteroid level to resource int level, and it's going to be a switch case construction, but it's just one way of doing it. You can actually have some complicated dictionaries of setups, but as I've said, it's a simple example. Case 0, and we can actually pause our game setup here. Setup, yeah, 0 means tiny. Tiny is, we will use the built-in tiny is length. Yeah, we don't need break if we have a return. Smalls. Here we have mediums. and we have one case left, which is a 3, but we will use it as a default to make the compiler happy, because if we use only cases, it will say that we don't always return something, so we need to return something, and it's going to be big by default. And we are going to just like entity dot add resource, map asteroids to level 2 resource, entity asteroid level. There is no, oh yeah, we need to pass our setup there. Setup. And now it's happy, and now we need to add it. And we need to add it right after the initialize asteroid system, because this is where things are going. Like we don't have any initialized asteroids, so let's add that. And a map asteroids to resource system. So this thing will trigger only once, like initialize asteroids. Let's put it actually here, and we'll place this thing here. So these are our initialized systems. Yeah, let's put them at the very top of it. So first we initialize player, then we initialize instantiate views, then we initialize asteroids. And yeah, if we initialize asteroids and then map asteroid level resources after we execute an instantiate view system, because it's a reactive system, it's not an initialized system, we will have our asteroids created only on the next frame. So this instantiate view will actually needs to be called after we mapped asteroid level to resources. Like this is where we add resources, and this is where we instantiate all resources. So this way all things happen at the needed frame. Yeah, let's check that. We haven't run it in a while, so I hope it works. Yeah, it doesn't work. Something should have gone wrong. Cannot get component view. Why can't we get a view component? We can't get a component from the rotate player system because we have our links here. Yeah, like we probably call our rotate player system because we instantiate view system before that. So this is where we instantiate a player. It has a resource but doesn't have a view. Then we try to rotate it, but we instantiate the view here. So yeah, order of the systems matter. So let's put our rotate player and replace acceleration systems after we instantiate views. Yeah, and usually this kind of things are handled using different kind of features. So you usually have some kind of a feature like view feature, which handles all the entities right after everything has happened. But in this case, we are bound to some kind of, yeah, and as you can see, our asteroids actually spawn but don't move. And what do we need to make them move? Who can tell? Who can say?
Initial position.
No, initial position, they are actually not spawned at their prefab positions, they are scattered. As you've seen, they are placed random every frame. What do we need to make them move? It's close, but we don't have that velocity component. We call it another name.
Yeah, we have the loop system. So.
We have what?
The loop system.
The move system, yeah, it uses which components? Yeah, nobody's following. Yeah, asteroids laser collision. Ah, that's nothing fancy. It will use a 2D trigger collider, so don't get too excited. Yeah, like what do we need to make asteroids move? We don't have a move component. We call it in. Let's check our move system and let's see what it uses. Yeah, we have a move system and it uses which component? Like, can you tell? Like, we have a group, and this group consists of entities with which components?
Acceleration.
Yes, acceleration and a view. We clearly have a view component on our asteroids, but we don't have acceleration. Yes, we need to add an acceleration component. And the acceleration is going to be random, and who knows how to make a random vector, like 380 degrees random vector.
What do you mean by that?
Like, we need to make the asteroids move randomly. Like, every asteroid should move like this asteroid should move this way, for example, or this way. This asteroid should move up, and so on.
New vector 3D with random components.
Random components for vector 3D will result in a non-normalized vector. So we need a normalized vector.
Dot normal.
We can make vector 111 maybe and multiply it by random some random value.
Yeah, if you have a vector 111, it's first it's not a normalized vector. It's yeah, and if you multiply it by another vector, it's just going to stretch it. It won't rotate it.
It's like Unity has the standard normalization function.
Yeah, but we don't actually need a normalized vector because asteroids will move with a speed of 0.3, for example. So we need a vector with the length of 0.3, but pointing at a random direction. So we need a random direction. We need a unit vector with a random direction, which we are going to multiply by this value. So maybe some chat guys know. Yay! We have a winner. It's Daniel Nagy. He says that we need to use some polar coordinates. Yes. And let me just copy and paste that. Polar coordinates are a very cool thing. It actually enables you to find a random value between 0 and 2 because angles are measured in pi in Unity. Like, we need to find a random number between 0 and 2, and we need to use this formula to find our vector, because like r is our 0.3, and cosine of this angle and sine of this angle is going to be what we really need. Like,
give us something like, I don't know, like maybe we will move around some point, no?
yes, we are moving. Yes, we just need to find a random rotation of our vector. So we rotate it by a random number.
Yeah, so it means that it should move some direction.
Yes.
But not
because asteroids have their speed set as constant.
Oh, we don't do gravity.
Yeah. Space doesn't have gravity. Oh wait, it does, but it's not what it looks like. Yeah, we are. Yeah, and now we have some random values, and we have our speed multiplied, and what do we have in the chat? Yeah, nothing interesting. Yay, they're moving. And the most interesting part, yeah, so they are floating. We won't actually handle the usual case in asteroids where the ship goes to one side and then reappears from another, but it will be a homework for you if you're interested. So this is where we actually got our hands on something moving, something shooting, but nothing is colliding and nothing is reacting with each other. And this is where we need to decide whether or not to use unity physics or something else. And in this case, just for simplicity, we will use unity physics as triggers. So we don't use unity physics for movement. We only use it for triggering. We can actually make a brute force collision detection, but I'm just going to show you how to cram different things together, using unity physics plus entitas, and it will actually use that another way of handling creating of new entities with new components. And yeah, let's see. First we need 3 layers of physics. Yeah, it's not here, it's layers. Player, laser, and asteroid. And layers are common both for 2D physics and 3D physics. Then we need to add actually a collider. And as you can see, Unity actually handles the collider size nicely, so I don't need to specify any radius. But for the player, we're gonna make it smaller just to make it more resilient for the asteroids. But for all other things, we are going to leave it as by default. One other thing that we need to collision, because of how Unity works and I guess Box2D works, is to actually add rigid bodies to all of our moving components, moving game objects. And as we move them ourselves, it needs to be set as kinematic. We don't need any physics materials, and we are okay with default setup. So yeah, we'll apply this one. And also a player layer. And our laser will have a capsule collider 2D. And as you can see, it even handles capsule collider nicely. It just fits pixel to pixel. And we need a
kinematics, and it means they won't crash on each other.
It's kinematic. If they are kinematic, it means that we move them ourselves. We don't need physics to move them. So we only, oh yeah, we don't need to
automatic collisions. I mean, it won't bounce from each other.
They won't bounce from each other. Yes, they won't bounce if we click this tick is trigger. It means that all colliders are transparent, let's say. But we can actually create an asteroids or asteroids. Oh yeah, no, we won't do that here. But you can actually do it if you want, like handling physics and bouncing if you need to. But in this case, we will use just triggers. So our player is a trigger, our laser is a trigger, and it also needs a rigid body 2D set to kinematic. And these asteroids will have circle collider 2D, which is a trigger, and is also a rigid body 2D, which is also a kinematic. Kinematic. Yeah, all good. Radius. Yeah, radius is correct. Let's leave it like that. And we need to change the interlayering collision thing. Yeah, my screen size is too small for this. Like asteroid doesn't collide with asteroids, lasers collide with asteroids but don't collide with lasers, players collide with asteroids but don't collide with layers or asteroids, or players, yeah. We have our laser colliding with asteroids, our player colliding with asteroids, and that's it. Hello. So we need to actually, like, first we need to rotate our laser at the direction it's pointing. And one way to do it is to actually, like, we need a view reference here. So let's create a simple system just for this. So like rotate laser system. And it's going to be a reactive system again. Just so our laser is rotated. And maybe in future we can...
Do we need a special system for that? For example, we don't just put it when we instantiate laser?
Like, I think this rotate laser system will be triggered only when we creating a laser, and the laser both has view and a laser component. So yeah, we will need a laser component too. Let's add that now. It will also help us when we are colliding things together, like laser component. And the laser component is going to be another flag component. It doesn't have any data except that it itself serves as data. Oops. And as we have created a new component, we need to generate. I think we have like 30 minutes more and we are done. Rotate laser system. Let me quickly make my another copy and paste thing. Here we need an instantiate view system, which is actually, where is it? Yeah. We need to have both. Which component do we need? Can you tell me?
We need to have view.
View, and if we are rotating the laser.
Laser?
Yes. So if we have both laser and a view, this system will be triggered, like when we add a view and it also has a laser there. So it's not necessarily means that it needs to add those components in one system. It can actually handle it with across multiple systems. Systems, not systems, it's system.
Can you remind me, is the view component means it's visible? Yes.
The view component only has a reference to a game object, so so it may be not visible, but if the game object is disabled. So yeah,
it means it has Unity instance.
Yes, it has a game object instance in Unity. So we need this instance only to handle the transform rotation. So because this is our way of handling rotation here. So it has view and is laser. And for every entity that was created, it most likely won't be more than one thing at a time. View, value, transform. And we also need a asteroid and acceleration. because asteroids have acceleration. We can actually we'll have it here, but just in this case we know that lasers have acceleration, but just to make sure, let's put it here and put it here. Entity has acceleration. Oops.
Why do we need acceleration?
We need, because acceleration is a vector, and we need to set an up vector of the transform. Yeah. View, transform. Acceleration is a vector, like it should be called inertia. But in this case, I have decided to call it up. Is axle.normalized, because this vector should be, I don't know actually if it normalizes it internally. I think it should, but just to make sure.
I think it's normalized.
Yeah, but let's won't leave Unity to decide. Let's do it ourselves. And we need to decide where to put it. Our laser is instantiated, and we need to put our rotate laser after the instantiate view system. Add new instantiate. Wait, rotate laser. Yeah, it should probably work, because in the preparation project I was actually rotating it. It doesn't rotate yet. Why do we need? I really don't remember what was the different view and resource. Resource is a prefab. So we add a prefab to our entity, and then we instantiate that prefab using a add view. So like resources don't necessarily need to be game objects, they can be strings. So we can load them from the resources folder, or they can be URLs to the asset bundle server or something. So this is just how things are usually done. Yeah, let's check that. Rotate laser, replace acceleration, shoot system. Do we have an acceleration, initial position, and resource? So rotate laser system, transform up, axle normalized. Let's here transform up. Maybe it's not settable. I don't know.
So we added the system.
Have we what?
Added the system.
Yeah, I think so. Wait, we have an acceleration component, a resource, a view component. Oh, I have forgotten. We have a laser component, but
we don't add it to the laser.
Yes, we don't add it to the laser. Shoot system, add a laser. Is laser is true. Why do we need resource component? Yeah, it starts rotating. And here's an interesting thing. We need to actually fire a collision event when the laser triggers, like enters the asteroid. And it's usually done by, like, who knows what Unity has for us to offer to handle physics, like yes, it has a on-trigger enter method, and we somehow need to hook up on that method, and the only way is to actually create a mono behavior script that will do it for us. So let's call emit trigger entity behavior, and in this case I'm going to leave this as a Unity component, because Unity components are the only way we can actually have those callbacks, like private void on trigger enter 2D and here other. And this is where we will just create an entity with some component and let our Entitas systems do their stuff. So yeah, we'll put this thing on our laser first. And let's actually debug log when this thing happens, like name plus other name. Possibly we will have our laser slash asteroid collision. Let's see. Yay! It actually first collides with the player and then collides with a big asteroid. This is where we have probably haven't unchecked something. Yeah, like player is colliding with asteroid but doesn't collide with laser. Just to make sure. Laser player unchecked. I don't know. Maybe because the laser is on the default layer, yeah. And our asteroids are probably on the wrong layer too. Let's check that again. Yeah, now it prints this correctly, like laser is collided with a asteroid. Now we actually need to pass this info to our Entitas systems. And for it, we are just going to make another component called collision component. And in this case, in this implementation, we will just link two game objects there directly, like first component. And I will show you another cool thing, which is called an entity index. It's used to query cached entities with certain components, like game object first. First is our laser. Let's actually call it a laser, because in this case it's always going to be a no. Let's leave it as first, because you'll have to replace it with a player or something. Second. And it's not a unique component because we can have a lot of collisions. We need to generate. And we can actually access our entity here. Yeah, it has a context shared instance here. It's a singleton, but I've seen people do some tricky stuff with dependency injection, so it's up to you. We'll use the simplest method here. So we are creating an entity outside our entitas, hoping that it won't break. Add collision. And our first object is this, and our second object is other. This is how we tie Unity physics to entitas. We can actually see that it creates new entities when collision happens. Let's check that. See, it has created like 3 entities because it has passed through several asteroids here. As you can see, it creates new entities with collision. Doesn't destroy them at the moment, but at least it has some links between which laser has hit which asteroid, so we can destroy our laser and split our asteroid in 2. So yeah, we need to now create another system, and you guys tell me which kind of system is it in which we need to split our asteroid on a collision.
Should be reactive system.
Yes, it should be a reactive system, like hit asteroid system. And I like to copy paste my reactive systems, so just a second. Reactive system, where is my reactive system? This is my favorite reactive system. I'll leave the collections generic in this time. Heat asteroid system. Which thing goes in the collector? We need to react on something. On which thing do we react?
React is a collision.
Collision, yes.
Collision.
And it should have a collision. Reactive, yeah, Yakov.
Why do we have to put it into place?
Yeah, once again, systems are executed one by one. They are not executed in parallel. So this system is executed before this one, and then after this system executes, and the order matters. Like in one system, we can trigger on, let's say, let's close this one. We don't need it. Like we trigger on a collision, and during our processing, we can actually remove that component from an entity, so it doesn't have a collision yet. But the internal functionality of reactive systems is such that it still retains that entity in its collector. So this is what we create when we say that we should create a collector. Collector only collects entities until we call release collected entities on it. So it collects new entities with added collision, but doesn't remove them from the collector when the component is removed. So this way we can actually react on something that is happening on certain times, but we don't need to actually have that component. For example, you can imagine audio effect. We don't need to actually know to have the exact link to the component or component data. We only need to know that this thing happened. So we don't need actual component. So this is why we need another filter, and this method is actually executed in the same method that in this thing is executed. So it only first it gets all of the collected entities and calls filter on all of them, and only puts entities which pass this filtering to this list in which we execute. So in this case, as we clearly need collision data in our execute method, we need to specify like filter that it actually has a collision. If we will have some kind of a sound effect system which will play a sound effect, we can actually just return true here because we won't need that data of that component. So we react on collision, but we don't need a collision because we don't use it here. But if we do use it, we need to specify that it still has a collision, because like it may be created here, like in hello world system we create a collision, then in this system it deletes a collision, and in this system we still need yeah, it's not a null pointer exception, it's entities doesn't have a component exception. Yeah, it's a bit different. Yeah, this is why we need these two parts. And there was an internal talk about like, do we actually need to specify our filter every time? Because like, as you can imagine, it's always like copy and pasting, like collision here, and in our rotate, yeah, some kind of rotate laser system. Here, like laser view and acceleration, use laser view and acceleration, and it was decided to leave it like this because it makes it more verbose, and you won't, well, you will probably have some unnecessary behavior, like unintended, but it's much harder to make that mistake. So this is why we need to actually specify it 2 times. And I have forgotten in which systems we have been. I think it was, yes, and it was called Heat Asteroid System. Yeah, collision. Has collision, and for each collision that we have handled. First is our, oh yeah, in this system we need to know which collision has happened. Like we need to know whether it's a laser collided with an asteroid, or it's a laser or like asteroid with a player. In this system we actually hitting an asteroid with a laser. This is why we need to check whether those game objects are lasers or asteroids, but we don't have a link. If you remember, like first entity collision first, it's a game object, like game object. We don't need to which object it's linked. It has an entity link there, but it's like it's too complicated, and I just won't go into that right now. I will just show you a cool feature of the code generator, which is entity index, and it will allow us to find an entity that is linked to this game object. All we need to do is find our view component, and as we don't have additional attributes here, we need to add them, entitas code generation attributes, and we need to put our entity index attribute here, and it will create some cool API which will allow us to get every entity that can possibly have this component. Like, indices are usually not unique. It means that there may be several entities with the same component values, but in this case we know that entity collision second. Yeah, and the cool thing is first entity, like what do we call it? Contexts, game, get entities. Yeah, Visual Studio Code doesn't, or I haven't generated. Yeah, I just close it just in case. Let's generate. I don't remember whether I generated or not. Yeah, like when you add an attribute, yeah, I have generated, nothing has happened. So yeah, hit asteroid system, and we will use this new API. Here, like, wait, contexts, game. Yeah, it still thinks, it's still thinking. Let it think. Yeah, get entities with view, and we can pass our view there, and it will find every entity that has that view. But in this case we are sure that the view is mapped directly to an entity, so we can add another thing. It's called single entity. It actually uses system.link there inside, so use that with caution, because link is not good for game development. Simon has promised us to remove it, but it's still there. So yeah, it will drop an exception, like if it has more than one, or if it doesn't have any, it will throw an exception, but in this case we are okay. So yeah, first entity is our laser, and we can actually destroy it. And let's leave it for now. I'll show you a common way of handling destroy. And second entity is our asteroid, and we need to actually create new asteroids from that. So we need to create 2 new asteroids from that one asteroid. So let's create new entities. It's going to be an asteroid, add asteroid, wait, entity. So it doesn't clash. Asteroid. And new level will be the current level, like second entity is our asteroid level. -1. And we will also need a random direction. This is where we could possibly like move this logic into a map, because it's always random. Random angle, where is random angle? Yeah, let's put this logic actually into our mapping. Map asteroid level. So it handles every speed, and speed is this thing. Yeah, this way we will have common logic in one system. This way we can have asteroid and initial position of an asteroid, and everything else is handled by another system. So this position will be initial asteroid position plus some random value, like second entity or second transform position plus some random value. It's not as random as putting everything, like I'll put even like 0.5 here. It's not as random as putting it all over the place, but it's a bit random. And let's just destroy the second view, just for now. Object, destroy, second, just to see how things work. And let's add this heat asteroid system.
And I guess we also have to destroy the object if it's too small. So,
yeah. This is where we are going to actually calculate, like, if the object is too small, then this, yeah, where's my system? Heat asteroids. This value will be like -1. Like, yeah, we need to double check it, yeah. After we shoot, we need to hit asteroid system. So map asteroids. We create our asteroids in the map asteroids. So contexts. Let's check that it works for now. Yeah, it almost works. Yeah, like I can imagine. I won't have that random range. I will just leave it like this, because I don't remember exactly how much can it be moved. And it also had some cannot add component initial position, because add initial position. Oh wait, there is a misspell here. It may be working correctly. Yeah, like, let's check it out. I have used another object, not this one, which already had initial position. I actually needed to handle the new one. Yeah, missing reference exception, because we are trying to move a non-existent object. Okay, let's not try to make it work like it shouldn't. As you can see, it creates quite a lot of objects, because our laser is not destroyed. We can actually mark our laser as non-laser, but in this is the place where I show you how the destruction is usually handled. Like, we have a destroy component, which is a flag component. It doesn't have any data. It lives in the game context.
We just replace the component.
Sorry?
We replace the component.
Replace which component?
So the one we have to destroy?
No, we mark an entity as is destroyed, yeah, and then we gather all destroyed entities and handle it there. So let's create a destroy system. Oops. Destroy system, which is going to be another reactive system. Yeah, like you can put it in the cleanup, but then you'll have to handle it with a group. I like to handle it as a reactive system. Yeah, we are almost there. Just hold on for a bit. Destroy system. Yeah, I need to find my favorite reactive system and copy it again. Where is it? Instantiate view. Destroy system. And this is where we put destroy component, and this is where it is destroyed. Is destroy. Doesn't look like. I think there is a like custom API generation something. I never used it. Like, but if you need to call it is destroyed, you can do it. Just check out the docs. Like, and for each entity that has been destroyed, we need to actually destroy it. Destroy. But before that, we need to destroy every like game object, unlink our game objects. Like if you, I wonder if it compile. If we run it now, you'll see that our Unity game objects actually have some interesting component game entity link, which enables us to look at the entitas side of it. So it's an entity link component, and it actually retains the entity itself. So it says that it retained by and entity link big one, so it's retained by itself. This is where we need to unlink the game object from an entity so it doesn't interfere with the internal entitas logic. Like if entity sees that something is retaining an entity, calling destroy, and it will say that something is retaining it, and I can destroy it. Maybe you have forgotten to unlink it. This is what we are going to do. If an entity has a view, like if it doesn't have a view, we can just destroy it. If it has, we have to do some additional info, some additional work on it. Entity view value. It's our game object. We need to unlink it, and to unlink it, we need to add Entitas Unity engine Unity. To unlink it, then we need to destroy it. Object.destroy view, and maybe something else. I don't remember. I hope not. Let's actually check that. Yeah, seems like it's okay. And we need to put this system at the very bottom of our common controller, like here. I will even put some additional lines. So this way, if any system marks an entity as destroyed, this system will collect it and will actually do some routine like destroying game objects and unlinking it and everything else. Like our first entity is a laser, and we need to destroy it. Is destroyed. Wait, it's a game object. Is destroyed. True. And our second entity is destroyed also. This way, in our hit asteroid system, they will mark it as is destroyed. It will do its thing. It will try to move them a bit further and all that things, and it will then go and destroy them. Let's check. I'm not sure whether or not the execution order is correct, and maybe we will have some additional collisions, but we'll get into that. Yeah, right now it actually starts working correctly. As you can see, the laser has hit 2 asteroids at the same time, but overall logic looks like it's working. It doesn't print us any errors. Yay, it has -1, and -1 is by default, and it means it's a big asteroid. We have a...
It's nice
yes, which we can't really win. Yeah, the only thing we need to do is check whether or not the second entity asteroid level is greater than 0. And if yes, we are doing this thing. If not, we just destroy it and be with it. Like,
That's a good feature.
yeah. Yeah. Seems like it's working. And we are already 3 hours into it, so I think it's time to wrap up. And there are like a lot of things that we haven't covered, like we don't have our UI or score collection or something, but it's going to be your homework. Like if you're interested, you can, I'll put this project somewhere in the issue. Like there is a issue here, streaming, like 576. I'll put a link here and you'll be able to hack with it and do some interesting things. Yeah, like that's it. Thanks for coming. I'll stop streaming and stop recording.